For greenhouse lighting, it is recommended to use T5 or Tate fluorescent lamps, as they provide high light output with good energy efficiency, have a long lifespan compared to other types of lamps, and emit a spectrum of light that is beneficial for plant growth. Given the humidity and condensation in the greenhouse, it is essential to use lighting fixtures rated for damp locations. These fixtures are designed to withstand moisture, preventing electrical hazards. When choosing a fixture type, consider vapor-type fixtures, which are sealed enclosures that protect the electrical components from moisture and condensation, or open fixtures, which are less expensive than vapor-type fixtures but require additional protection from moisture. When mounting and wiring, mount fixtures above the drip line of the plants to prevent water accumulation. Use suitable weatherproof junction boxes and connectors for all wiring connections below the drip line. Ensure all wiring is secure and protected from damage or moisture. There are additional considerations to take into account. Firstly, determine the optimal light intensity for the plants that are being grown. Secondly, set up timers to control the lighting schedule. Thirdly, space the fixtures appropriately to ensure even light distribution. Fourthly, provide adequate ventilation to help circulate air and prevent excessive humidity and condensation. For the greenhouse application, it is recommended to use T5 or Tate fluorescent fixtures rated for damp locations with vapor-tight enclosures. The selection of appropriate lighting for a greenhouse environment requires careful consideration of several factors. These factors include lamp type, fixture construction, and environmental conditions. In this context, fluorescent lamps, particularly T5 and Tate variants, are frequently chosen for their energy efficiency, longevity, and spectral output suitable for plant growth. Damp location ratings are crucial given the inherent humidity and condensation typically found in greenhouses. Fixtures must be designed to withstand moisture to prevent electrical hazards and ensure reliable operation. Vapor-type fixtures, characterized by their sealed enclosures, offer enhanced protection against moisture ingress, making them a preferred choice for demanding greenhouse environments. Alternatively, open fixtures can be employed, but they necessitate supplementary safeguards to mitigate moisture exposure. Proper mounting and wiring practices are paramount for safety and performance. Fixtures should be positioned above the drip line to avoid water accumulation. Weatherproof junction boxes and connectors should be utilized for all wiring connections situated below the drip line. Securing wiring and providing adequate protection against damage and moisture are essential for maintaining a robust electrical system. In addition to fixture selection and installation, several other considerations warrant attention. Optimizing light intensity is crucial for promoting healthy plant growth. Different plant species have varying light requirements, so tailoring the lighting system to meet the specific needs of the plants being cultivated is essential. Implementing timers to regulate the lighting schedule allows for precise control over the duration of light exposure. This is particularly important for plants that respond to photoperiod, or the length of day and night. Careful spacing of fixtures is necessary to achieve uniform light distribution across the greenhouse. Uneven light distribution can lead to variations in plant growth and yield. Adequate ventilation is vital for managing humidity and condensation levels within the greenhouse. Proper ventilation helps to circulate air, preventing the buildup of moisture and reducing the risk of fungal diseases. When selecting fluorescent fixtures for greenhouse applications, T5 and Tate models rated for damp locations with vapor-tight enclosures are highly recommended. These fixtures offer a balance of energy efficiency, durability, and protection against moisture, ensuring optimal performance in challenging greenhouse environments. Choosing the right lamps involves assessing their spectral output. Plants require specific wavelengths of light for photosynthesis, with chlorophyll and chlorophyll B being the primary pigments involved. These pigments absorb light most efficiently in the blue and red regions of the spectrum. Therefore, lamps with a spectral distribution that emphasizes these regions are generally preferred for promoting plant growth. However, it's important to consider the specific needs of the plants being grown, as some species may benefit from additional wavelengths, such as far red light. Beyond spectral output, lamp efficacy, measured in lumens per watt, is a key consideration for minimizing energy consumption. T5 and Tate fluorescent lamps are known for their high efficacy compared to other types of lamps, such as incandescent or high-intensity discharge lamps. This can result in significant energy savings over the lifespan of the lamps, reducing operating costs for the greenhouse. The lifespan of the lamps is another important factor to consider. Longer-lasting lamps require less frequent replacement, reducing maintenance costs and downtime. T5 and Tate fluorescent lamps typically have a lifespan ranging from 20,000 to 40,000 hours, depending on the specific model and operating conditions. In addition to the lamps themselves, the design of the fixtures plays a crucial role in their performance and longevity. Vapor-tight fixtures are designed to protect the lamps and electrical components from moisture and dust, extending their lifespan and reducing the risk of electrical hazards. These fixtures typically feature a sealed enclosure with a gasketed lens or cover to prevent the ingress of water and contaminants. Open fixtures, on the other hand, do not offer the same level of protection against moisture and dust. These fixtures may be suitable for greenhouses with relatively low humidity levels and minimal condensation, but they require additional precautions to prevent water damage. This includes ensuring that all wiring connections are properly sealed and that the fixtures are mounted in a location where they are not directly exposed to water. Proper installation and maintenance are essential for ensuring the safe and reliable operation of greenhouse lighting systems. All wiring should be performed by a qualified electrician in accordance with local electrical codes. Fixtures should be securely mounted to prevent them from falling and causing injury or damage. Regular inspections should be conducted to identify any signs of wear or damage, such as cracked lenses, corroded wiring, or loose connections. Any damaged component should be promptly replaced to prevent electrical hazards. Effective greenhouse lighting involves considering the light intensity required by the plants. Light intensity is measured in units of photosynthetic photon flux density, or ppfd, which represents the number of photons in the photosynthetically active radiation range from 400 to 700 nanometers that strike a surface per unit area per unit time. Different plant species have different ppfd requirements depending on their growth stage, environmental conditions, and other factors. Generally, plants grown in greenhouses require higher ppfd levels than plants grown outdoors due to the reduced light transmission through the greenhouse covering. The optimal ppfd level for a particular plant species can be determined through research or by consulting with experienced growers. Once the optimal ppfd level has been determined, the lighting system can be designed to deliver the appropriate amount of light to the plants. This may involve adjusting the spacing, height, and wattage of the lamps, as well as the reflectivity of the greenhouse walls and ceiling. Controlling the duration of light exposure is another important aspect of greenhouse lighting management. Photoperiodism is the physiological response of plants to the relative length of day and night. Many plant species are sensitive to photoperiod and will only flower or produce fruit under specific day-length conditions. For example, some plants are short-day plants, meaning that they require a long period of darkness to initiate flowering. Other plants are long-day plants, meaning that they require a short period of darkness to initiate flowering. By controlling the duration of light exposure, growers can manipulate the flowering and fruiting of plants to meet market demand. This can be achieved through the use of timers, which automatically turn the lights on and off at predetermined times. In addition to light intensity and duration, light quality, or the spectral composition of the light, also plays a crucial role in plant growth and development. As mentioned earlier, chlorophyll and chlorophyll B are the primary pigments involved in photosynthesis, and they absorb light most efficiently in the blue and red regions of the spectrum. However, other pigments, such as carotenoids and anthocyanins, also play important roles in plant physiology, and they absorb light in different regions of the spectrum. Therefore, it is important to consider the spectral composition of the light when selecting lamps for greenhouse lighting. Some lamps, such as full-spectrum lamps, emit light across the entire visible spectrum, while others emit light primarily in the blue and red regions. The optimal spectral composition for a particular plant species will depend on its specific needs and environmental conditions. Maintaining a consistent and uniform light distribution is essential for ensuring optimal plant growth and yield. Uneven light distribution can lead to variations in plant growth, with some plants receiving too much light and others receiving too little. This can result in reduced yields and lower quality produce. To achieve uniform light distribution, it is important to carefully space the lamps and to consider the reflectivity of the greenhouse walls and ceiling. Reflective materials can help to bounce light back onto the plants, increasing the overall light intensity and improving uniformity. Adequate ventilation is crucial for preventing excessive humidity and condensation in greenhouses. High humidity levels can promote the growth of fungal diseases, which can damage or destroy plants. Condensation can also drip onto the plants, creating a breeding ground for pathogens. To prevent these problems, it is important to provide adequate ventilation to circulate air and remove excess moisture. This can be achieved through the use of fans, vents, and other ventilation equipment. In addition to natural ventilation, mechanical ventilation systems can be used to control the temperature and humidity levels in the greenhouse. These systems typically consist of fans, heaters, and cooling units, which are controlled by a thermostat or other environmental controller. By carefully managing the temperature and humidity levels in the greenhouse, growers can create an optimal environment for plant growth and development. The selection of appropriate lighting for a greenhouse environment requires a comprehensive understanding of plant physiology, electrical safety, and greenhouse management practices. By carefully considering the factors outlined above, growers can design and implement lighting systems that promote healthy plant growth, maximize yields, and minimize energy consumption. Ultimately, the goal is to create an environment that is conducive to plant growth and development, allowing growers to produce high-quality crops efficiently and sustainably. Remember to consult with qualified professionals and adhere to all applicable codes and regulations when installing and maintaining greenhouse lighting systems. Safety should always be a top priority.